Hello, we are starting very soon. I want to be sure that everything is clear. Please, if you're online, you can indicate. If you're active, please, you can indicate. If you're active, please indicate. If you're active, please indicate. Please, I want to be sure, is the video clear? I hope it's clear, so we can start. Let's keep pushing. Hello, are we active? Hello, are we active? We are about starting. We are about starting. Please, let's keep sharing the group link. Let's keep sharing the group link. Let's keep sharing the group link. Please, if you're active, please indicate that you're active. Indicate your presence so we can proceed. All right. Okay. Please, if you're active, indicate your presence. All right, guys. So we're going to be starting very, very soon with intensive class. Starting very, very soon with intensive class. All right, so I'm trying to test the microphone, ensure everything is in proper state. I hope the videos are clear. All right, guys, so we are starting our class now. We are starting now, so let's keep on sharing the link for other people to join. Okay, so we want to continue with complex number where we stopped in our previous class yesterday. Yesterday we talked about complex number in details, right? I hope you all can hear me. Please, if you can hear me, indicate in the comment section. Please indicate. Yesterday we talked about the foundation of complex number, where we say that complex numbers are those numbers that have two major parts, right? Which are the real parts, uh, and we also have what we call imaginary parts, imaginary parts, imaginary parts, right? Then we say that the general form of complex number, we are looking at complex number, right? Complex number. We say the general form of complex number is z equals to x plus yi, or z equals to a plus bi, right? Where x or a represents the real parts, y or b represents the imaginary part of complex number. And the reason why we call y imaginary, or the reason we call b imaginary, because it has a complex value called I attached to it. And yesterday we were able to analyze that the value of I in complex number is equal to square root of -1, right? While the value of I squared is equal to -1. That anytime we see I represents the root of -1, -1, while I squared represents -1. Then we talked about how to derive I. We talked about how to evaluate I. We then look at some basic operations in complex number. We talked about the modulus of a complex number, which is also referred to as the length or the size or the magnitude of complex number. We also talk about how to find conjugate of a complex number, how to multiply, how to add two or more complex number, right? Then how to divide two or more complex number. And in division, we looked at how to rationalize the denominator and so on and so forth. Please, if you are in this class, make sure you visit the previous class we had yesterday on complex number. Everything has been discussed in detail. In today's class, our emphasis will strictly be on the polar form of a complex number. Polar form of a complex number. Like we mentioned yesterday, we have various forms of complex number. The first form is the general form, where we say z equals to x plus yi, right? We also have a form called the polar form. And we say that every complex number, right, is made up of two parts, which are real and what? Imaginary. The real represents x, imaginary represents what? Y. Then we can represent a complex number in a diagram called an Argand diagram. Called an Argand diagram. Called an Argand what? Diagram. Okay? Using the Cartesian diagram, we can locate where a complex number can be constructed or can be fixed in a diagram called what? An Argand what diagram. Okay? Or using a Argand diagram rather. All right. So my emphasis today will be on how to analyze, how to find polar form of various complex number in general form, how to transform general form of complex number to polar form of complex number. Then from there, we also look at how to transform polar form of complex number into other form like the Euler form, the cis form, and we also look at the movie Theorem and so on and so forth. Today, I will make sure I conclude on this topic today. All right. Now, let's start the journey. Polar form of complex number. Polar form of complex number. Okay. Look at this. We say the general form. Sometimes they call it the triangular form, right? Is given as z equals x plus yi, right? X plus yi. I can transform this into a form called what? Z equals to r cos theta plus I sin what? Theta. This is the polar form here. This is the general form we all know, right? Now, how do we do that? Let me just show us how to transform this to this. Looking at the Cartesian diagram, okay? We say that if z equals to x plus yi, both x and y are both positive. That means they can fall in, or they're falling rather, in the first quadrant of this Cartesian diagram. How the first quadrant? Well, all is positive, right? Y axis is positive, S is positive. In this quadrant here, which is the second quadrant, Y is positive, S is negative. In the third quadrant, Y is negative, S is negative. In the fourth, X is positive, Y is negative. Since I'm considering a general case whereby both X and Y are both positive, that means the value of my Z will fall in here, right? And if you follow us yesterday's class, we say that this part here, the longest side, which is the hypotenuse, right? Okay, is called the length of the complex number, also called the modulus of the complex number, right? So we call the Z equals to what? Z modulus equals to what? R, right? Now look at this now. In the complex plane like this is called the y-axis, right? This is called what? The x what? The x-axis. Okay. Now what I'm going to do is to resolve horizontal components and vertical components. If I'm to resolve in resolution, okay, I will resolve x with respect to what? Y. Looking at x represents the adjacent. Y, the longest side represents what? The hypotenuse. If I'm to find the value of x, or resolving x, I will use x and what? R, the longest side, right? Which is OA. If I'm to resolve for y, I will use y and the hypotenuse as well. Now let's look at resolving x. Resolving x means s, which is the adjacent, right? And what? Hypotenuse. From what we have, from the word SOHCAHTOA, I hope we can all see the board, right? From the word SOHCAHTOA. Okay, we are all seeing the board because I have an indicator here, right? Okay, from the word SOHCAHTOA, if you look at it very well, the right trig to use here is car, right? Because S represents the adjacent, while OA represents what? The hypotenuse. Let's put B here, okay? Okay, now that means that I'm going to say using cos what? Cos theta, right? Equals to, cos theta means adjacent over hypotenuse. Adjacent is x. Hypotenuse is what? Is r. By the time we cross multiply this, x times 1 will give us what? S, right? S equals to what? R cos what? Cos theta, equation 1. What we did here is that we just cross multiply, right? X times 1 is x. R times cos theta is R cos theta. Now, I've been able to resolve for x. That means x component represents R cos theta. What will be the value of y? Let's resolve y. I know I say that if I'm to resolve y, I will resolve y with respect to this r, right? And that simply means that y represents the opposite because any side that faces the angle is called the opposite. Then OA, which is the hypotenuse here, right? This is the hypotenuse. So I have here the opposite, I have the hypotenuse. It means I will use what? Sine, right? I'm going to say using sine what? Sine theta, which is equal to sine is opposite over hypotenuse. Opposite is y, over hypotenuse is what? Is r. The same thing we did in this first case will be repeated here. I'm going to cross multiply, right? This over 1. Y times 1 is y. Y equals to r sine what? R sine theta, equation what? 2. Are you there? But recall. Let's finish up this. Recall that the general form is giving us x plus what? Yi, right? That will give us z equals to, the value of x we got here is r cos theta. I'm going to substitute my equation 1 and equation 2 into the general form. And that will give us what here? X represents what? R cos theta, right? R cos theta plus y represents r sine theta. Here we have r sine what? Theta. Then times I. Okay, times I. Then we're going to have here as between these two terms, what is common is the value of the modulus, which is r, right? So r is common here in brackets. If r is common, that means what will be left here will be cos theta plus what? I sine what? I sine theta. If I'm to bring out the value of r here, when you divide this with r, I'll be left with cos theta. When you divide r sine theta I with r, I'll be left with I sine theta. So this form is called what? The polar form, right? The polar form of a complex number. Of a complex number. Please take note of this. This is the polar form of a complex number. All right. So you can take note. Then let's look at some other aspects of this. Now, how do we convert from general form to polar form? From general form to polar form. Very important. Okay. I hope people are online. I hope you guys are following up. Please, if you are following, let me see your indication that you're following. Please indicate in the comment section that you are following. And please help me to share the link. Share the link to your departmental course mates. Please don't just remain. Don't just be enjoying this alone. Go off and share the link. Encourage people to join. All right. I want us to have up to 30 members online tonight. Please, let's keep on sharing the group link. Let's keep on sharing the group link. All right. Okay. So let's move on. All right. So let's define some terms here. There's a term I want us to define in the polar form. Okay. Now there's what we call argument. Argument simply means theta. Either it means theta. We also call this axis. Axis. Huh? Axis. The word axis means what? Theta. Sometimes they use the word amplitude to also represent theta. This is also called what? Amplitude. Okay? Also called amplitude. Either. Now, if we are to find arguments or find theta when the value of z is equals to x plus yi, right? In the first quadrant. If the value of z is equals to x plus yi, to find theta, to find the word argument, we're going to use the word tan theta, which is equals to y over what? X. Tan theta equals to this, where theta is equals to tan inverse of y over what? X. All right? Although we can use sine, we can use what? Cos. Okay? When the value of x and y are both positive. I will explain this. But just take note that the arguments, the angle here, if I have a polar form rather, which says what? R cos theta plus what? I sine theta. Right? That implies that Z represents the complex number, right? In polar form. R represents what here? The modulus or modulus or the length of Z, right? The theta represents arguments, also called amplitude, also called arg-Z. Arguments, or we'll call it what? Arg-what? They're not arguments, arguments. All right. So please take note of this. Take note of this. Okay, so let's look at some cases, some special case. This is where I want every one of you to pay attention. I'm going to teach now. You likely must have not seen this in any textbook. These are my secrets I want to share online under complex number. All right, these are my secrets I would like to share. What I want to do now is something you have to pay attention to. Okay, now listen. We have several cases I want us to look at under polar form. The first case is, let's look at case 1. I'll be explaining and be cleaning at the same time because the board is not wide enough. The first case is a case where z is equals to x plus yi. Don't forget that in the Cartesian diagram, there's the one we use which is called cast. Here we have A, right? Here we have C, we have X, and we have what? T. We use the three trig functions to represent Cartesian diagram. A means all is positive. A means what? All is what? Positive. Meaning your sine, your cosine, and your tangent are positive here. And any angle we have in the first quadrant, they are called what? Acute what angle? They are called what? Acute angle. So for the first quadrant, where the angle is acute, all is positive, meaning your sine theta, your tan theta, your cos theta, tan of that acute angle, sine of that acute angle, cosine of that acute angle is equal to what? Positive. And what acute angle? this angle less than 90 degrees, right? The angle less than 90 degrees. Now, if you look at this here, sign, x means only sign is positive. Whenever the value of your complex number falls in here, I will use sign to find what? The argument or the reference angle. There are two different angles I'll be explaining here. I will draw the diagram for us. We have what we call the reference angle and what we call the standard angle or the directional angle. We have the reference angle. We use alpha to represent reference angle. Then we have what we call the standard angle. And we use what we call theta to represent the standard angle. So just follow me step by step. Just know that in the first quadrant, all is positive. The standard angle is equal to what? The reference angle, meaning alpha equals to what? Theta in the first quadrant. I will draw them. Then in the second quadrant that says only sign is positive, that implies that my standard angle is simply 180 minus what? The reference what? Angle. I will explain. All right, I will explain. Okay, but just to note that whenever the value of your z falls in here, I will use sign to find the what? Reference angle. Then after getting the reference angle, I cannot get what? The standard what? Angle. In this quadrant here, A, both y, this is positive y, abi? This is what? Positive what? X. Both y and x are positive. So I can use any of these three to find. I can either use sign, because sign is positive. I can use what? Tan. Tan is what? Positive. I can use what? Cos. Cos is what? Positive. For this quadrant here, only sign is positive. That means my tan is negative. Tan is negative. Why cos is what? Negative. But sign is what here? Is positive. For the third quadrant, T means tan. It means that only tangent, tan, is what? Positive. Are you following somebody? Tan is positive. That means that my sign is what? Negative. And our cosine is what? Negative. For C, you can tell me what C represents, right? C means cosine. And that means that only cosine is positive. So, here means only cosine is positive. Here sine is negative, while tan is also what? Negative. So take note that for the first, all is positive. Sine, tan, and cosine are positive because we have the first quadrant. For the second quadrant, only sine is positive, but tan and cosine are what? Negative. For the third quadrant, only tangent, T means only tan, is positive. That means that sine and cosine are negative. Cosine means only cos is positive, but sine and tan are both negative. Now let's look at it here. For the first case, what does this first case represent? It represents the first quadrant. The first quadrant, because both x and y are both what? Positive. If I have minus here, the value of my z can no longer be represented or located in the first quadrant. Do you get the concept here? Because here, our x is what? Positive, but y is what? Negative. It means that I can locate this in the fourth quadrant. If both x and y are both negative, it simply means that they can only be located in the third quadrant. But if y is positive and x is negative, it means they can be located where? In the second quadrant, because x is negative, y is positive. Don't forget, here we have negative x, and here we have negative what? Y, right? Okay, but let's look at the first case. The first case is when both are positive. This is the diagram here. The diagram when we have both positive, is this. I want to explain this. If my value of my z is x plus yi, let's say for example, let's say we have z equals to 3 plus 4i. Definitely, I will locate this where in the first quadrant. So the value of my z can only be captured in the first quadrant of a Cartesian diagram, right? Okay. So that implies that here becomes, here we have our y, here we have our x, here we have our alpha is equals to theta. Don't forget that I say that in the first quadrant, the reference angle is equals to the directional angle or the standard angle. Theta also means what? Standard angle. Alpha represents what? Reference what? Angle. Why are they both the same? Because in the first quadrant, there is no rotation. There is no rotation of angle. No rotation of angle. All right? We can only rotate from year to year. Okay? We have only small rotation rather. I can only rotate from year to year. You must take note also that a lot to learn here. You must take note that the value of theta is always measured from positive x-axis. Positive what? X-axis. While the value of our alpha is always measured from is always located rather on positive x or negative what? X-axis. We can only measure theta from positive what? X-axis, which is from this axis, right? From this axis here. This is positive x. So theta is measured here. So from year to year, we have our alpha equal to theta. And second again, alpha is always found either on negative x-axis or positive x-axis. In this case here, alpha is found where? On the positive x-axis. So alpha equals to theta. Are you following, guys? Okay. So for this quadrant here, it simply means that my value of my alpha is equals to what? To theta in the first quadrant. When the value of your z falls in here, x plus what? Yi. Alpha equals to theta. Alpha represents reference angle. Theta represents standard what? Angle. So for me to find my alpha, I can either use any of these three, Gabi. I can either use sine, use tan, or use what? Cosine. Right? Why? Because z is in the first quadrant. So any of these can go because it falls in the quadrant that says all is what? Positive. Now let's look at the second case. The second case is a case where x, our value of x is negative, then y is what? Positive. I think this will become more clear. Okay. Look at this case here. If you look at this case, this is a case where x is negative. I have negative x. I have positive what? Y, right? So the value of my z will fall in here. Are you there? Will fall in here. If it falls in here, I can complete my right angle what? Triangle, right? Okay. All right. Here remains our value of r, which is what? Z what? Modulus. Here remains our what? Our x minus x, right? This is what here? Our positive y. This is the y-axis. This is the x-axis, right? Okay. This is our negative what? X, right? Now, alpha, reference angle, can be found on either, for the first one, our reference angle is here, right? Right? Reference angle alpha is always found on the x-axis. It's always found. That is the angle the x-axis made with the hypotenuse. That's for the reference angle. Any angle the x-axis makes with the hypotenuse is called what? Reference angle. That means for this diagram, I'm going to have my reference angle here as alpha. All right? Then standard angle is always measured from the positive. I mentioned it here. Is measured from the positive what? X-axis. That means I'm going to start from here and stop here. This is my standard angle. from this positive x-axis down to this hypotenuse line. I will not cross this line. And what do we call angle in a straight line is 180 degree, right? If total angle on a straight line is 180 and I carve out this, that means from this region to this will be what? Theta equals to what? 180 minus what? Reference angle. The reference angle is the angle the x-axis makes with the hypotenuse, with the modulus line, with the length of the complex number, right? Good. But standard angle is the angle measured from the positive x-axis down to that same line. So if from here to here is 180, and we call the reference angle, that means here will be what? 180 minus what? Theta, which is equals to standard angle. Now for this, don't forget that because the value of our z falls in what quadrant? In the second quadrant that says only sign is what? Positive. That means the right page to use to find our reference angle will be what? Will be sine. So to find the reference angle, I'm going to say sine what? Sine alpha. And sine is from what? So, which is opposite over what? Hypotenuse. My y is my opposite, right? Over what? Hypotenuse, which is what here? R. Therefore, me, I can say that our alpha equals to what? Sine inverse of y over what? R. Alright? So from here, we can be able to determine the value of our alpha. Then when you get the value of your alpha, you know what to do, right? Just subtract that value of alpha from 180 to find what? The standard what? Angle. Alright? And don't forget that in 3, there are 2 ways of representing an angle. Angle can be represented, right? In degrees. Hope you're aware. In degrees. Number 2, it can also be represented in what? In radian. In radians. And don't forget that 2 radian is equals to 360 degree, while 1 radian equals to what? 180 degree. Why I'm bringing up this is that after finding your theta, your angle measurements, according to those in Imo State University, your angle measurement, your theta, your standard angle must be in radian unless otherwise stated. Unless otherwise stated. That means there must be a conversion. By the time we continue, I will explain how to convert from degree to radian. All right? Okay. But just know that we have 2 ways of measuring angles. You can measure angle in terms of degrees. You can also measure angle in terms of what? Radian. I hope you are following. Please, if you are following, indicate in the comment section. All right. So let's look at this. We have seen the second case, right? Let's look at the third case. The third case will now be a case where both x and y are negative. Case 3, right? Case 3 will be z equals to minus x minus yi. Let's represent this. Now look at this now. If I'm to represent this, what do you think it will fall in? Where both x and y are negative in this quadrant, right? Good. So that means that I will draw a straight line. Don't forget that when you draw the straight line, you have to look for how you can construct a right angle or triangle. Will you like go this way or go this way? That's the question I know some of you are already asking. Will I go this way or will I go this way? Don't forget that the first thing we need to do is to determine where the reference angle is falling, right? And the reference angle is always the angle the x-axis makes with the hypotenuse line. This is already the hypotenuse line. This is the length of the complex number. Where do we have the x-axis? This is the x-axis. So that means that from this region here to this region will be our reference angle. That angle the x-axis makes with the hypotenuse. Or we can always say that reference angle is found along the x-axis. So that means I'm going to construct my triangle this way, right? Then after getting this, the next is to determine the standard angle. But let's bring out this. Here we have minus y, right? Here is what? Minus x. Here we have r equals to what? Z what? Modulus, right? So where do you think will be the standard angle? Standard angle is always measured from the positive x-axis, meaning this is my positive x. I will start from here, right? And go this way and stop here. So that means that our theta here is equals to 180 plus what? Reference angle. For this, for the second quadrant, theta is 180 minus. But here's what? 180 plus. You know why? We started from here. We covered 90, right? We cover 90 again, making it 180. We now cover alpha, which is our reference angle. And that gave us 180. Meaning from here to here is 180, then plus what? Alpha. That gave us our standard angle for this. So because the value of Z falls in the third quadrant, what do you think will be the right trade to find the reference angle? Of course, it should be tan, because tan is positive in this quadrant, right? So that means that to find my reference angle, I'm going to use tan what? Tan alpha, which is from the word to our right. Opposite is minus y over adjacent is minus x. Are you there? And this will give us what here? Y over x, right? Because minus can cancel what here? Minus. Are you seeing the reason why it is very important to use the right trig in the right quadrant? Because if I'm to use sign here, definitely the sign at the end of the day, I will have a negative value. The essence why it is important to use the right trig for the right quadrant is that at the end of the day, you end up having a positive value. So that by the time you are looking for your reference angle, you will not need to start manipulating or you'll be confused or anything. So from here we have tan alpha equals y over x. So alpha here becomes what? Tan inverse, right? Tan inverse of y over x. Tan inverse of y over x. Then this is how to find our reference angle. But don't forget that after getting your alpha, to find the standard angle, I have to add 180 to the reference angle. Now let's look at the last case, which is the case 4. Case 4, meaning the fourth quadrant. Case 4. For case 4, this is a case where the value of our y is negative, ys is positive. That means x minus yi, right? X minus yi. X is positive, y is negative. So the value of our z will definitely fall in here, right? Just draw a straight line. By now, you should know better. You should know where to locate the reference angle, right? Reference angle is the angle the x-axis makes with the hypotenuse line. This is the x-axis, right? It means this is my reference angle. Then I can complete my right angle triangle this way, right? Here we have minus what? Y. Here we have x. Here we have r equals to what? Z what? Modulus. Then how do we find our directional angle or standard angle? Theta is from here. Theta is measured from the positive x-axis. It means I will start from here and I will end here, right? I will not go beyond this line. Hope you are aware. I won't go beyond this line. So that means that my theta is simply, look at this, total angle at a point in a cycle is 360 degrees, right? So that means 360 minus this will give us from this region to this region. So the standard angle here is 360 minus what? Reference angle. Not 270 plus reference angle. I've seen many people who make so many mistakes. I don't know how they justify that the theta here is 270 plus alpha, but that is not true. The right standard angle here should be 360 minus what? Alpha. Now let's solve some good examples from your textbook, all right? From your textbook. We are given this question. We are told that given that z equals to 1 plus I, we are given, okay, express z equals to 1 plus I in polar form. Let's start with this question first before we go into other questions. Express z equals to 1 plus I in polar form. Alright? Now, to express this in polar form, we look at the nature of the complex number given to us. What are the sign convention, and where will this value of z fall in what quadrant can this be located? These are the questions you have to ask yourself first before you start solving. Don't just delve into problem and start solving. Look at the nature of the problem you are given before you start solving. Already we are given that z is equals to 1 plus what? I, right? Of course, both x and y is positive, right? For this question, our x is 1, y is what? 1. Good. Our real part is 1, imaginary part is what? Is 1. So what we do is to construct the Argand diagram. We call all of those diagrams I do. Okay, we call them Argand what? Argand diagram. They are called Argand diagram. So definitely this will fall in here. All you don't need to do is to draw a straight line. Yeah, okay. Then bring out your right angle triangle. Here we have that our alpha is equals to theta. Don't forget, the value of our x is 1, value of our y is also 1, right? Here we have that r is equals to what here? Z what? Modulus. Are you following? Okay. So the next thing we need to do is to find the value of r using what we call Pythagoras what? Theorem. Using Pythagoras theorem, or using what we call the modulus. I taught you guys how to find modulus, right? In the previous class, the modulus of z is equals to what? R, which is equals to square root of what? Of x squared plus what? Y squared. So R becomes what here? Root of 1 plus what? 1 square rather, plus 1 squared. Is that not? And that will give us square root of 1 square plus 1 square will give us root 2. Okay. Now, we've been able to get the value of our R. All right. The next is to find the argument or the reference angle first. The reference angle. The argument, which is our z, is same as your standard angle. Don't forget, okay? Your argument, z, is equals to what? Theta, which is same as what? Standard what? Standard angle. Okay? Don't forget. Please take note. So let's go. Now, like I said, since this falls in the first quadrant, I can use any of the three functions. I can either use sine, I can use cos, I can use sine, I can use tan, right? Because it falls in here where all is positive. Because the angle here is called what? Is called acute what? Angle. So that means I can say using, let me just use tan to solve. Using tan alpha, tan reference angle equals, the word tan is from the word tua, which is opposite over what? Adjacent. Our opposite is 1. What's the adjacent is 1. So here we have 1 over 1. So that means our tan alpha is equals to what? 1. I hope you are all following. Okay? And alpha is equals to what? 1. Alright. So from here we can find tan inverse. So alpha becomes tan inverse of 1.000, right? Yeah, alpha should be around, I guess, 90 degree, right? Alpha is around 90 degree. Okay, please, if you are following, indicate in the comment section. If you are following, indicate in the comment section. If you are following, indicate in the comment section. So alpha is 45, sorry, and 1 is 45 what? Degree. Okay, but recall that in the first quadrant, we say that alpha is equals to what? Theta. Alpha is equals to what? Theta. Okay, which is equals to what? 40 what? 45 degree. Therefore, our theta standard angle is 45 what? Degree. But I say that in polar form, your angle must not be in what? In degree. Your angle should be in what? In radian, unless otherwise was stated. Unless otherwise stated. So what we do is to convert, right? Pardon me, my calculator is to convert this, and that will give us. Okay, let's convert this now. Listen. To convert it simply means our theta, just multiply 45 with 1 radian, then divide by what? By 180. Alright? 45 can go in itself. 45 here will give us what? 4. And that will give us what here? 1 radian over what? Over 4. Okay, I'm going to explain this so we can understand how to convert. Please take note of this. Okay, let me quickly clean this. Alright, so look at this. Let me show you how I converted this. We have our theta to be 45 degree. And we say that 1 rad equals to what? Equals to 180 degree. Don't forget, 1 rad is 180 degree. So how many rad will give us what? Can we find in 45 degree, right? So what we do is, of course, multiply this. That will give us what here? 180x equals to 45 times theta is 45. Okay. All right. Sorry, I'm making a mistake here. Yeah, we say that we call that 1 rad is equals to what? 180 degrees. So how many rad can we find in 45 degree? Can we find in 45 degree? So we cross multiply this, right? 45 times rad will give us 45 rad equals to what? 180 times x, right? So that means my x becomes what? 45 rad over what? Over 180. Are you there? If 1 rad represents 180 degree, how many can we find in 45? That means x equals to 45. What we just did there was to cross multiply this. 45 times rad is 45 rad. 180 times x is what? 180x. Then to find x, we divide both sides by what? By 180, right? And that gives us this. Instead of following through this long process, the easiest way to convert is to just multiply this 45 with 1 rad, then divide by what? By 180. So far, you will not follow this process of conversion. You don't need this process of conversion. Just multiply the 45 degree with rad and divide by what? 180 degree. Okay. So from here, we can cancel, right? 45 here is 1. I guess here will give us 4. That will give us 1 rad over what? Over 4. Yes. 1 rad over 4. So we have seen that our arguments theta. Therefore, our argument theta is rad over what? 4. Then recall, we are converting this to polar form. The polar form is giving us r cos what? Cos theta plus I sine theta. So that means our z equals to, develop our how we solve. How represent what? Root 2. Don't forget, root 2 cos our theta is rad over 4 or pi over 4 plus I sine pi over what? 4. This is how to convert to polar form. So this form is called what? The polar form of a complex number. Polar form of a complex number. Let's look at another wonderful example from your textbook. Please, if you are following, indicate in the comment section. Indicate in the comment section if you are following. Indicate in the comment section if you are following. Indicate in the comment section. If you are following, please indicate in the comment section. If you are following, please indicate in the comment section. I want to see your reply. Are you guys following? I need more reply. I need more reply. I need more reply. If you are active, please indicate. All right. All right. So let's solve more examples from your textbook. From Imo State University textbook. We'll solve more example. All right. Let's solve more example from Imo State University textbook. Are we ready? Example 2. Example 2. Let's look at another case where we have z equals to minus 3 plus 3i. Z equals to, express in polar form, express z equals to minus 3 plus 3i, right? Minus 3 plus 3i in polar form. I want to be sure we are solving the right problem. Okay, let's solve this together. Look at this question. Yeah, we want to express this in polar form. Solution. The first is that we need to look out for where this falls in, right? In the Cartesian diagram. Here we have negative x and we have positive y. So that means this falls in here. Oh, are you seeing me, guys? This falls in here, right? Okay. So here we have our reference angle. Here we have our directional angle, which is theta equals to 180 minus reference angle. Don't forget. So yeah, the value of our x is minus 3. The value of our y is 3, right? Not 3i. It should be 3. Then here we have what here? R. R equals to what? Z what? Modulus. So the first is to find the value of R. Let's find this, right? So using R equals to Z modulus, which is equals to square root of x squared plus what? Y squared. So that means our R equals to square root of what? Our x will give us minus 3 all squared plus y will give us 3 squared. So the value of R becomes what here? Square root of what? 9 plus 9, right? Then R equals to what? Root 18. Root 18, right? And let's see how we can reduce 18 to the basic form. 18 to the basic form. 2 can go in 18, which is 9. 3 can go, which is 3. 3 can go, which is what? 1, Abi. If you look at this, I want to reduce this. This can be reduced to basic form. But I would like to teach the online students on how to reduce this to basic form. We call this complex form of surd. We want to convert from complex form to basic form. So we bring out 18. Divide 2 can go in 18, we have what? 9. 3 in 9 is what? Is 3. 3 in 3 is 1. These 3 appears how many times? 2 times. I will just split them as 1. 2 appears how many times? 1. So I'll just put my surd on it. So 3 times surd 2 will give us 3 surd 2. That means surd 18 can be expressed as 3 surd 2, right? 3 surd 2. Okay. So that means we have gotten our value of R, right? Now the next is to find the argument. But before we find the argument, theta, We have to find the reference angle. Look at this. This falls in what quadrant? In the second quadrant that says only sign is what? Positive. Here we have all. We have sine. We have cos. We have tan. So I'll use sine to solve, right? I want to say using sine alpha equals to sine alpha will give us from the word so opposite over what? Over hypotenuse. What's the opposite here? Is 3. What's the hypotenuse? Is 3 root 2. 3 root what? 2. Right? Yes, let's repeat again. Sine alpha is opposite over hypotenuse. Opposite is 3 over 3 root 2, right? Okay, and that will give us 3 can go with 3 here, right? We're going to have it to be sine alpha equals to 1 divided by root 2. I guess this should be about 0.7071. So what do we get here? Alpha becomes sine inverse of 0.7071. So let's punch calculator to determine the value of alpha. Let's punch calculator. What do you think will be the sine inverse of 0.7071? Okay, that should be 45 degree. 45 degree, right? So the value of alpha here is 45 degree. Okay, but the reference angle is not what we are using to determine the polar form, right? We're going to look for the standard angle, which is what our arguments, right? But recall that since Z falls, right, falls in the second what? Quadrant, theta is equals to 180 minus reference angle. 180 minus reference angle, and that will give us about 135, right? So our theta becomes 135 degree. But don't forget that we say that the arguments or theta must not be in degree, but what? In radian, unless otherwise stated. Unless otherwise stated. So what we do is to convert this to radian. That will give us 135 radian over 180 degree. I think by the time we divide, this will give us about 3 radian over what? Over 4. When you divide this will give us about 3 radian over 4. 3 radian over 4. Okay. Now the next is to express what we have here, right? In polar form. In polar form is to express this in polar form. Now what are we going to do here? I want to clean this. So let's express in polar form. So what we do is to recall, right, that the value of Z equals to what? R cos theta plus I sin what? Theta. So that means our Z becomes, our value of R we solve is about 3 root 2, right? 3 root 2. Okay, in bracket we have cos. Our theta is 3 pi over 4 plus I sin 3 pi over 4. Final answer. Final answer. All right. Are you seeing how simple this can be, right? This is how it is. If the value of Z falls in the third quadrant, you do the same thing by adding. That means to find my theta in the third quadrant, I will add 180 plus alpha. If the value of Z falls in the fourth quadrant, do the same thing. Just subtract the reference angle from 360 degree in the fourth quadrant. Just like that. All right. Okay. Let's see if we can solve one more example for third quadrant. One more example for third quadrant. Guys, are you guys following? Are you guys following? Are you guys following? Are you guys following? Please, let's share the group link. 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 share the group link. Let's share the group link. Are you guys following? If you are following, let me see your charts. Let's keep on sharing the group link. Okay, next example should be something. Let me look for something that will give us fourth quadrant or third quadrant. Okay, let's look at this question. If we are given that is equal to we are asked to express this in polar form. Express in polar form. Express minus z equals to minus root 3 minus 3r in polar form. We are asked to express this in polar form. Now, what we do is to locate where this will be, right? In the Cartesian diagram. Of course, the value of our x and y are both negative. So they are both negative. Here we have negative x and negative y. So that means they will fall in somewhere here, right? Don't forget that here becomes what? Our reference angle, right? Alpha is here. Okay, the value of our y is minus 3, while the value of x is minus root 3. Then here we have r equals to z what? Modulus, right? Then the standard angle is measured from here to here, right? Which is theta equals to 180 plus reference angle. Don't forget this, okay? So the next is to find the value of our r, which is z modulus, equals to square root of x squared plus what? Plus y squared. So that means our r becomes square root of the value of x is minus root 3 all squared minus root 3 all squared plus minus 3 all squared, right? Square can cancel square root here. We are left with r equals to square root of, here we have here to be 3, right? No, 9 rather. Of course it's 3 because if square cancels square root, we are left with just positive 3. Okay, because we have square, this minus becomes what? Positive, right? So plus square of minus 3 will give us what here? 9. By the time we add up 3 plus 9, that gives us about 12. Now let's see how we can break this down. If I have 12, what can go in 12 is 2. We have 6. 2 can go, we have what? 3. What can go again? 2, we have what here? We have 1. Sorry, 3 rather. 3, we have 1, right? So how many 2 do we have here? We have 2, 2. I will take them as 1. 3 appears just 1. I'll put my root on it. So here we have 2 times root 3. That will give us what? 2 root 3. So the value here is simply 2 root what? 3. Okay? 2 root 3. That's the value of our r. Now the next is to determine what will be the nature of the reference angle. Okay? Since the value of our z falls in the third quadrant, so the right trig to use is tan, right? I was going to be using tan. I'll say using tan alpha equals, tan is from the word toa, right? Which represents opposite over adjacent. Opposite. The side facing this angle is minus 3 over adjacent. So I'm going to have minus 3 over, all right, minus root 3, right? So this will give us, this can go with this. We're going to have tan alpha equals, let's divide 3 with root 3. Let's divide 3 with 3. Divide 3 with 3. 3, okay, divided by root 3. That will give us about, sorry, that will give us about, sorry, about 1.732.1, right? So from here, you can see that alpha equals to tan inverse of 1.7321. So let's look at tan inverse of this shift and tan inverse of the answer. That will give us about 60 degrees. So alpha is equals to 60 degrees, right? Equals to 60 degrees. That's the value of our alpha, right? But don't forget that this alpha represents the reference angle, right? So what we do to find the standard angle, since Z falls in the what? In the third quadrant, right? I can say that our standard angle becomes what? 180 plus what? Plus 60. So standard angle becomes 180 plus 60 will give us about 240 degrees. So the next is to convert 240 degrees to is to convert 240 degrees to radian, right? This gives us about 40 radian over what? 180. Let's can go here. Okay. I think 6 here, 4, 18 divided by 6 was about 3. This is about 3. So our reference angle becomes 4 pi divided by 3. Okay. That's our reference angle, 4 pi divided by 3. So from here, we have been able to determine our reference angle. The next is to express in polar form. So expressing in polar form, I want to say recall, right? Recall that Z equals to what? Our cos theta plus I sin what? Theta. So Z becomes the value of our R. What we determine as the value of our R? That should be about 2 with 3, right? Our limit is about 2 with 3, right? In bracket, we have our cos theta becomes 4 pi over 3 plus I sine 4 pi over 3. Final answer. So we are done with polar form. Now I want us to look at what we call how to multiply and divide polar form of complex number. How to multiply and divide polar form of 2 or more complex number. Are you there? How to multiply or divide 2 or more complex number. Okay. Please, are you guys following? If you are following, please indicate in the comment section. If you are following, please indicate. If you are following, please indicate. If you are following, please indicate. And I hope the video is clear. Please, if you are following, please indicate in the comment section. Indicate. Let's keep on moving. Indicate. Now, multiplication of polar form and division of polar form of complex number. Multiplication and division of polar form of complex number. Very important aspect that we need to look at, okay? Please write. Note that to multiply two or more polar form of complex number, we have to multiply the value of the arrows and add up the angle. For example, let's say if I have my Z1 to be equals to arrow 1, okay, cos theta 1 plus I sine theta 1, all right? Then we have that Z2 equals to R2 in bracket. We have cos theta 2 plus I sine theta 2. Now, if we are to multiply this, I will explain this using, I will use this example to explain both multiplication and division, all right? If we have to multiply, please note, to multiply, the principle here is that I'll multiply this arrow and add up what? The angle, all right? And add up the angle. Okay, so to multiply, that means the first is Z1 times what? Z2. Z1, Z2. That will give us, I'll multiply arrow 1 times what? Arrow 2. Then in bracket, the principle says we're going to add up the angle, which is theta 1 plus what? Theta 2. Are you there? Plus I sine theta 1 plus what? Theta 2. This is very simple, right? It's very simple. If I have Z1 in polar form and Z2 in polar form, to multiply Z1 with Z2 in polar form, the principle says multiply this, then add up the angle. But to divide, to what? To divide. If I'm to divide in polar form, let's say we have Z1 divided by what? Z2. The principle is almost the same. I will divide R1 with what? With R2. Then I believe that you can tell me the rest, right? What do we do to the arguments? The angle, we subtract. In multiplication, we add the angles, right? Then in division, we have to subtract the angle. Here becomes theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Okay, this is just the result of what we just have. Now let's look at some examples on this. How can we apply this to solve basic problem in complex number? For instance, let me just give an example. Then we'll move down to the Moivre's theorem. We'll move down to the Moivre's theorem. If we are given that Z1 equals to 2 cos 40 plus I sine 40, and Z2 equals to, let's say, 4 in brackets, we have cos 70 plus I sine 70. Look at this now. Notice that the argument is in the green. If the argument is in the green, just solve in the green, all right? Then at the end of the day, you can convert your answer to what? To radian. Okay, so let's go. To find, let's say we have to find Z1 times Z2. What we do here is multiply the arrow, right? 2 times 4 is simply 8 in bracket. Then the rule says, after multiplying this, we add up the angle. That's what the rule is saying. And that was what here? Cos 110, right? Well, I can just say, of course, can just say cos 110 plus what? I sine 110. Don't forget, multiply 2 by 4, we have 8. 40 plus 70 is 110. So cos 110 plus I sine 110. The good thing about complex number in polar form is that any angle you have here must be repeated on this other side. You can't have 110 here and have another different angle here. It's not possible in polar form. Number 2, let's say we have to find Z1 Okay, let's say Z2 divided by Z1. Okay, and that will give us here, I will divide 8 by 4, right? 8 over 4. Exactly. Okay, 8 over 4 will give us what here? 2 in bracket. And that will give us cos. The same way we added, right? So for this case here, we are going to subtract, right? We're going to subtract. And that will give us cos 40, right? Okay, because 110 minus 70 will give us what? 40, right? 110 minus 70 will give us 40. Then plus I sine 40. I want to believe that this is clear. Please, let's keep on sharing the group link. Let's keep on sharing the group link. I hope this is clear. Is the video still blurring? Is it still blurring? Is it clear now? Is the video still blurring? Oh, it's still blurring. Are you guys sure? Is it blurring or is it clear now? Please indicate. Okay, it's clear. All right. So can we proceed? Can we proceed further? All right, guys. So let's proceed. Let's proceed. And don't forget that at the end of the day, you convert this degree to radian, right? Which is about 40 radian over what? 180, right? Over 40 over 180. Then you can cancel out. Then leave your final answer in radian, like we did in the previous example. Now let's go into the Moivre's theorem. The Moivre's theorem. The Moivre's theorem. Okay, the next one is the Moivre's theorem. The Moivre's theorem. Okay, the Moivre's theorem is a very simple theorem, all right? And I'll be explaining this theorem. I'll also give an example of this theorem. The theorem states that to raise a complex number in polar form, okay, to the power of n, we multiply the we raise the complex number to the power of n and multiply the arguments, the angle, by n. I repeat again, to raise a complex number to a power of n. The Moivre's theorem is also called power of a complex number in polar form. And that name is called power of a complex number in polar form. Complex number in what? In polar form. In polar form. That's another thing, and that name is called power of a complex number in polar form. The theorem says that to raise a complex number to a certain power n, we have to raise the entire complex number to the power of n. We raise the r rather to the power of n and multiply the arguments by what? By n. I repeat again. To raise a complex number in polar form to a power of n, we raise the r to the power of n and multiply the argument, which is the angle, right, by n, and multiply the argument by n. That's what the Moivre theorem is talking about. All right. Okay, I'm coming. Let me get a general expression for that. Okay. What I'm saying here is that if we are given, let's say we are given that z equals to r, right? R cos theta plus I sine what theta in polar form. Right there? So what the Moivre theorem is saying is that to raise a complex number in polar form to a power of n, we have to raise the value of the r to the power of what n and multiply the argument by what? By n. By what? By n. What I'm saying is that if I'm to raise my z to a power of n, the principle says that the whole of this is simply r, right? Cos theta plus what? I sine what? Theta, which is raised to the power of what? Of n. The Moivre is now applied by saying that I have to raise this r here to this power of n. Here becomes r raised power n. Then in bracket, I'll multiply the argument theta with n, which is cos theta n plus I sine what? Theta n, or n theta. Most of the time we use n theta. Let's use n theta, n theta. This is very simple here. We are saying that to raise a complex number in polar form to a power of n, meaning 0 per n, which is equals to every part of the polar form raised to the power of n. The rule is saying I have to raise the value of the r to the same power of n and multiply the argument by n. That's called the Moivre theorem. All this clear, right? So can we look at one or two examples from the textbook? Okay. Please, if you are following, indicate in the comment section. Please indicate in the comment section. Okay, the board is not clear again. Is the board not clear? Someone is commenting that the board is not clear. Is the board not clear again? Is the board not clear? Please check for me if the board is clear. Is the board clear? Okay, well, okay, some person we are complaining that is not clear. Please, a minute, let me get a past question. Okay, let's look at one example. I'm so sorry for the delay a little. Hello, are we there? Okay. All right, guys. Let me just give you guys one or two example. Then we proceed from here into past question, into some past questions. All right. If we are given that z equals to 2, let's say z1 equals to 2 cos 30 plus I sine 30. And we have to find z1 raised by 2. The only way to solve this is to apply the Moivre's theorem, because why, we are given a power of n, right? Here our n is equals to 2, right? We are given a power of n. So applying the Moivre's theorem here, we're going to have here to be z1 raised by 2 equals to 2 raised by 2. The rule says I have to raise this r to the power of n, right? Then multiply the argument, the angle, by what? By n, and n is 2. And that will give us what here? Cos 30 times 2 plus I sine 30 times 2. And that will give us z1 all squared equals to 2 raised by 2 will give us what here? 4. Here we have cos 30 times 2 will give us 60 plus I sine 60. Just like that. This is just how to solve a problem under the Moivre's theorem. Under the Moivre's theorem. Don't forget that at the end of the day, I will convert this angle to radian, right? Angle will be converted to radian unless otherwise stated, right? So by conversion, we say 60 pi over what? 180, right? 0 can go with 0. I guess here we have 6 here 1, 6 here will give us 3. 1.5 pi over what? Over 3. So at the end of the day, the value of our z1 square becomes what here? 4 cos our 60-degree is pi over 3 plus I sine pi over what? 3. Okay? All right, let's see past question. Past question. Please, if you are online, indicate. If you are still online, please indicate. If you are online, please indicate. Let's look out for past question now. If you're online, please indicate that you're online. This will enable us to progress. If you are online, indicate. Okay, let's look out for a question here. Yeah, I've seen the question in your past question. Question says that question here says if z1 equals to 2 cos 10 plus I sine 10 and z2 equals to 3 cos 25 plus I sine 25. And the question says that we should find question 1, z1 to the power of 3. Question 2, z2 to the power of 2. Question 3, z1 to the power of 3 times z2 to the power of 2. All right. So this is the equation we have here. We are given here to solve. Okay, I want to believe that we can solve this, right? We can solve this together. Okay, let's try this question together, right? Let's try this question together. Are you there? So for this question, we are given, okay? All right, let's solve this together. I'm just verifying what we have, all right? So we are asked to find z1 raised to the power of 3 first. z1 to the power of 3. For the first one, I will solve the first, you will solve the second and the third, all right? Then this class will be over. Now for the first one, we are asked to find z1 to the power of z1 to the power of, so let me take the question again. z1, sorry for the little break. z1, okay, we also obtain, z1 to the power of 3. This will give us, my n is 3. I'm going to have it to be 2 raised to 3, right? Okay, in brackets, and that will give us what here? Cos 10 times 3 plus I sine 10 times what? 3. Then we close the brackets, right? We close the brackets. Is that not? Okay. That's for this. Okay, so let's go. Here we have 2 raised to 3 is actually 8, right? And that will give us what here? Cos 10 times 3 is cos 30 plus I sine 30 degree. This is just the answer to the first question. Then number 2 says we should also find z2 to the power of 2. z2 to the power of 2. And that will give us, our z to the power of 2 will give us what here? 3 raised to power 2, which is about 9, right? 3 raised to power 2. Are you there? 3 raised to the power of 2 in brackets. Then the rule says when you raise the value of r to the power of n, multiply the argument, right? We have cos 25 times what? Times 2 plus I sine 25 times 2. Okay, so this will give us what? 3 raised to power 2 is 9. In bracket, we have cos 50 plus I sine what? 50. All right, guys, I'm going to stop here for today because the weather is very bad and my network is not stable. So I want you guys to solve the third one. I get the third one says z1 raised to power 3 divided by z2 raised to power 2. So what we do is to apply the division rule. It means I will divide this, right, with this. So what we have, we divide 8 with 9. Then we subtract the argument, the argument is 30 minus 50, right? We divide the value of our r to divide this in complex number. We divide this with this, right? Then I'll divide my 8 with my 9, then subtract the argument. But if I'm to divide z2 raised to power 2 with z1 raised to power 3, I'm to divide this with this. Let's say I'm to find my z2 raised to power 2 divided by what? z1 raised to power 3. It simply means I will divide this, right, with what? With this. Then also subtract 50 minus 30 for the argument. All right, I want you guys to please take out your time to go through all the lectures for today. All right, I'm trying to rush the class because I believe that this part of complex number is now simple. It's very easy, right? So my next class, the last class, is how to find the nth root of a complex number. Nth root of a complex number. Tomorrow, by the same time, I will try as much as possible to be consistent online in the evening, so we can be able to have intensive class throughout, both in physics, chemistry, maths, and biology. All right, just do me a favor, ensure you share the link to your classmates. Let them have access to this video. This video will be uploaded on our YouTube channel. You can always go back there to watch and to learn and to recall on what we have discussed so far. All right. Thank you.